that might occur once more. When things first started, there was an endless, compact, microscopic ball of substance. Then, everything fired up at once, leading to the stars, galaxies, atoms, and molecules we observe today, or that's what. For years, physicists have informed us that. Decades, but contemporary theory. Research in physics has revealed a new viewpoint indicating that the cosmos might not be as old as previously believed, that instead it might be a cycle of activity in which the universe experiences several explosions, bounce cycles that have happened at least once and maybe in an infinite. Renowned loop scientist Brian Cox additionally disputes the theory of the Big Bang, saying, such object is incapable of emerging from nothing, enhancing James's sense of intrigue. The Webb Telescope has achieved an amazing finding that defies the theory that the Big Bang was the starting point of the cosmos. This revelation inspires the issue whether or not the Big Bang was whence the universe first began, and what was it? Let's look for uncertainties. Scientists are well knowledgeable about the earliest known universe and love as the Big Bang theory, according to. In this idea, there existed a considerably smaller cosmos, warmer and denser in the distant past than today is that first day of Inferno 13.8 billion years ago. Every component that shape us into who we are were created in the duration of almost 12 minutes as per. According to this theory, the entire cosmos, the galaxies, stars, and everything else was once peach-sized and with a greater than a quadrillion degrees Celsius. Degrees. Unexpectedly, this fantastic tale is in line with every observation made to date. Astronomers have investigated everything ranging from residual electromagnetic radiation from the earliest universe to the quantity of the lightest components and ascertained that everything aligns with the Big Boom forecasts. As far as we are aware, this is a true representation of our early universe. Even so, we are aware that the Big Bang theory is not exhaustive. There is a jigsaw piece missing, and it's the beginning of the universe itself, which is a sizable portion of the difficulty we encounter in comprehending the universe resides in the bounds of the physics ideas that we now use. Combining high theory with general relativity, particle physics of energy gives us a foundation, but when we go more deeply into the early times of the universe, the mathematical intricacy increases in intensity to a certain point. If our existing techniques fall short of offer significant solutions, one of the signs that there is yet undiscovered territory is an area where there is singularity, an endless dense point situated at the Big Bang's beginning captured. Literally, this implies that the universe was once condensed into an thick and infinitely tiny state that is obviously absurd. As opposed to taking this at face value reveals what it says, that in order for us to overcome new physics, this obstacle, our current arsenal is simply inadequate. Sufficient to save the day will require a few, something that can manage new physics, the other forces and gravity, concurrently at really high energies. And string theory is exactly what asserts that it is a physics model that can managing the forces of gravity and other combination at extremely high energy levels. That indicates that the claims made by string theory describe the initial stages of the universe. In string theory, the idea of an equatoric universe appears, taking its name from the word meaning in Greek. Consequently, conflagration or fire notion of the Big Bang that we all know was brought on by an earlier incident, proving that it wasn't the last, not the start, but rather a segment of a bigger procedure. Expanding on the idea of equatoric has produced a theory inspired once more by cyclic cosmology, a term from string theory. Although the notion of a universe that repeats has been thought upon for countless years, string theory offers guidelines for having a strong mathematical basis. The circular universe functions as one might visualize, pulsating between massive explosions and severe shortages in a never-ending loop. stretching unendingly back in time, and in the future, this cyclic cosmology theory was proposed by well-known physicist, the Nobel laureate Roger Penrose. 2020 prize. Penrose found it fascinating that an amazing mathematical connection among the early universe described due to its extraordinary smallness and heat density. When the Big Bang occurred in the anticipated, the universe's future condition, which is it to be very cold, expanded, and meaningless, is revolutionary. According to theory, these two states become equivalent in mathematics when pushed to the brink, even if it can appear. The paradoxical lack of matter completely could be the motivating factor, the process by which all of the matter we perceive in the cosmos in accordance with this viewpoint, the Big Bang is the source, from an almost invisible remnant that was left once all of the universe's matter has been devoured by black holes, which ultimately vanish into lost photons inside a huge void. So the whole, the universe is created out of something that, from an alternative perspective, is practically as near to nothing as. But one may envision this emptiness is still a variation of what it makes up the physical universe, even while a vacant one. The question is, how? The same condition can be understood as a hot, empty universe as well as a frigid one, dense universe. Based on the point of view, there's a complicated mathematical method known as conformal scaling, a geometric process, change that modifies the dimensions of an item while keeping its form. Penrose showed that the frigid vacant, both the warm, dense state and linked by means of this rescaling, matching the architecture of their space-time. Despite the differences in their sizes, it's difficult to understand how, in this case, two items can be identical, weight even as their sizes differ. Penrose, though, contends that the idea, size, is no longer relevant in these severe environmental circumstances. In conformal cycles in cosmology, the order of things develops from a chilly, ancient state to a youthful, warm state. The existence of the cold causes a hot, dense condition to form, empty state, but this causal connection does not adhere to the standard pattern of cause a temporal preceding effect. In these severe conditions, size and time loses its traditional significance. The heated, thick state and the chilly, empty states have their own timelines apart from the viewpoint of a bystander within its own time period. The cold, the vacant state would last forever. However, it provides a heated, dense state, rise to take up a whole new. On its own, a chronology can be helpful in. Imagine the hot, thick state emerging from being established in or made aware of by, in a non-causal setting, the cold, empty state, in which these ideas possess metaphysical ramifications and have been thoroughly investigated by scientists, philosophers, especially when it comes to quantum gravity, where customary concepts of it appears that cause and effect falters when we came to the end of our knowing. The domain of physics and philosophy combines and transforms. Difficult to distinguish between conformal cyclic cosmology offers theoretical but thorough justifications for the genesis of our great explosion, because even if Penrose's concepts receive backing in the future, breakthroughs in cosmology that they might not answer a more profound philosophical query about the genesis of the material world itself. How did the whole framework of cycles are created, which brings us to consider the cause of the existence of something as opposed to nothing, which is among the essential philosophical queries. Nonetheless, for our discussion's goal will be to concentrate on justifications in the field of. In physics, there are three primary options to take into account when investigating the beginnings of these cycles. To start, because there might not be any explanation at all. In addition, could be an unending chain of events that repeat, with each interval standing in for a unique universe. The first quantum, every universe's condition would be based on a certain facet of the lastly, the universe that existed before it. the single cycle option is available, and an endless universe in which the cycle's beginning is clarified by a attribute of its own conclusion. The final two opportunities are alluring because they do not require random occurrences and offer a thorough justification. In the context of physics, Penrose places, putting forward the notion of an unending series of new cycles that are impacted by his quantum theory interpretation in quantum mechanics, a system of laws existing concurrently in several states, till it is noticed, at which time it collapses into a single state at random. According to Penrose, every cycle is affected by arbitrary quantum occurrences, resulting in changes from cycle to cycle. This idea has potential consequences for physicists who do experiments, since it makes the prospect of detecting minute remnants or irregularities in the radioactivity remaining after the Big Bang, which the Planck Observatory has noted. Satellite Penrose and Associates thought they might have done so already, discovered these traces linking specific trends within the Planck data to supermassive black hole radiation. But in the earlier universe, other physics experts have presented objections to the legitimacy of these agreements, and the observations are still ambiguous. The most recent revelations made by the results of the James Webb Telescope have notable alterations in the area of, as they defy the state of our current understanding of the cosmos and could call into question the veracity of atheists who believe in the Big Bang Theory have found 6 enormously massive old galaxies, which are deserving of the Monica universe breaker because of their enormous size, and these galaxies were active at a certain age, when there were only 3 universes percent of its current age, which is significantly sooner than expected for the galaxies of such size, in accordance with established hypotheses that the early universe ought to have been inhabited by little, young galaxies throughout this historical period. But the discovered galaxies are mature and massiveness comparable to the Milky Way, offering a bewildering mystery for scientists. The presence of such massive galaxies so close together, nearness to the Big Bang, presents the general comprehension of early galaxy formation based on current models. After a time of rapid expansion, the cosmos cooled, allowing gas to combine and crumble, producing the emergence of galaxies and stars during. Despite the Dark Ages, the discovery of these enormous galaxies implies that, though they may not have been not as active as before, thought that Dr. Emma Chapman, an astronomer from the University of Nottingham, stated that these results suggest that the universe went through a lot of star creation much early. More than expected, additional observations and thorough examination will be necessary to confirm these findings and determine their consequences for cosmological frameworks that were established. The study group hopes to obtain spectral photos that will provide more accurate measures of distance and facilitate improved calculations of the galaxies. Mass spectral analysis will be important, crucial part in confirming the existence of these items and releasing additional, shedding light on their nature in an unexpected way. The nature of these results highlights the constantly changing field of scientific understanding and the need for revision ideas in the face of fresh evidence, even though it's too soon to firmly reject the Big Bang Theory. The discovery of these enormous old galaxy threats to our existing cosmic context and demands a reevaluating our comprehension of the early cosmos.